So this question wants us to construct the right angle triangle and then solve based on what we're given and what the unknowns are. So I'm going to cheat because I can. And we're going to make it look like that. Okay, there's my triangle. What are you telling me? In triangle ABC, so the name of this is A, B, and C. The C angle is 90, so this is C. B is 3 and A is 6. No, does not matter. So the way we label sides is the little letter is opposite of the big corner. So I've got two sizes here. I've got 3 and 6. I want my 3 to go here, even though this is so not to scale. I want the 3 to go there and the 6 to go there. So that means if the 3 represents B, then the opposite angle is our B angle. And if the 6 represents A, the opposite angle is our A angle. So that's an important thing to know when you are working with triangles. So this wants us to solve it. When you see something that says solve, it's finding all of the values. Okay. First thing we can do a little A squared plus B squared equals C squared. We can do that. That would be good first step. Then it wants us to find some angle business. Let's talk about that angle, and let's talk about, I used theta, let's use beta. Okay, so we need to solve for those two angles as well, meaning we're going to have to use trig ratios. Okay, so let's go. C squared equals A squared plus B squared. Plug in the things that I know. Oh, there's totally a diagram that's already been made for this, but I'm not going to use it because it's more fun watching me struggle. A was 6 squared, B was 3 squared, C squared is 6 squared, 36 plus 9, 36, 46, 45. And C is positive or negative root. You can't have a negative root as a measurement. So it's only the positive root of 45. Let's break it down. Can't touch this. 9 and 5. Root 5. Okay, that's what C is. Grade 9, we would have left it as root 45. Grade 11, we know better. So then the next thing I'm going to do is solve for theta. If I'm solving for theta, I have to use the sides based on the theta given angle. Yes, we're going to solve for this later, but I'm not going to worry about that right now. So across from 90 is the height. Across from the given angle is the opposite. And then the other one is the adjacent. So when I'm solving for theta, I'm going to use blue. We know all of the sides. I know this side, I know this side, and then we found out something really cool and complicated for C squared. It was what? 3 root 5? Nobody wants to do math with that. So it's like, yeah, good for me. I can find that hypotenuse. I'm a great math student, but if I have an option, I'm going to pick the relationship that just uses the 3 and the 6. Thanks for coming out, 3 root 5, but I don't want to use you. So if I just want to use the relationship with the opposite and the adjacent, I'm going to have to use tan of the angle because tan is opposite over adjacent. So SOHCAHTOA, tan, opposite over adjacent. 3 over 6. That would mean tan of the angle is 0.5. And then let's undo tan to find what the angle is. And we get Second tan 0.5. Oh, 26.57, 26.6. Let's go 26.6. What does it say in the question? It just says solve. I didn't tell you how many decimal places, but I'm going to go 1. Let's solve for beta. Again, we have to change our side names based on the given angle. So the opposite side of beta is right there, and the adjacent side of beta is right there. Hypotenuse just stays hypotenuse. But we're going to have to, when we're due, I'm going to use tan again, because why would I want to use any other numbers than 3 and 6? My opposite and my adjacent are going to be different. So tan of beta is the opposite side over the adjacent side, which is tan beta of 2. We're undoing with the same color. I hope you can handle that. And then we're left with beta is second tan of 2, 63.4, I'm just doing one decimal place, 63.4 degrees. Does that make sense? Well, we know one corner is 20, we know the other corner is 26.6, and the third corner is 63.4. Add them all up, 180. Life is good.